From now on, I will be explaining more HMMT problems. What is HMMT, you might ask? Well, HMMT is a math tournament hosted by Harvard University and MIT. It differs from other math competitions such as AMC because of its team setting and complex problems. In HMMT, students choose other students to be in their team to help them figure out complex problems. It also contains a wide different factors in math, such as number theory, geometry, and algebra. With that being said, let's jump into HMMT problems. We are given that a and b are positive integers. A to the power of b is 2 to the power of 23, and we want to find what the smallest possible value of b to the power of a is. The first thing to notice is that the smallest possible positive integer value is 1. So we have to make b to the power of a equal to 1. How do we do that? It's actually quite simple. So we let a be equal to 2 to the power of 23. So now we can let b be equal to 1. See, this doesn't change the value at all, because 2 to the power of 2023 to the power of 1 is 2 to the power of 2023. So the smallest value of b to the power of a is equal to 1 to the power of 2 to the power of 2023, or equal to just 1. Now, that being said, we already figured out the first problem. Now we have to figure out the second. We are given that a, b, and c are integers. We want to find what the smallest value of the square root of c times the square root of b times the square root of a, and we want to find what the smallest value of a, b, and c is, like a plus b plus c is. Alright, so since they have to be integers, and from this, the numbers are all in the square root, so we know that they're all positive. So they're all positive integers. So the first 3 integers, since we want to find the smallest value, the first 3 integers is 1, 2, and 3. So 1 plus 2 plus 3 is 6. So we can already write a statement. A plus b plus c is greater than or equal to 6. Because the 6 is the sum of the first 3 integers. We now know that 6 doesn't work. So we try another group of numbers, 1, 2, and 4. Now there are 2 squares in this. So we actually have a good solution here when a is 2, b is 4, and c is 1 is equal to 7. But the 4 and 1 can switch around. Here, let me show you. So the square root of c, which is just like 1, the square root of 1 times the square root of 4 times the square root of 2, right here. This is just 1 times the square root of 4, which is 2. So 2 times the square root of 2 is just 2. So you can switch these around, but in the end, you get the same output.